So today we're going to start a review on linear relations, standard form, calculating some slopes and things like that. What standard form is. It's a review. It's kind of a first day of a couple day review on linear functions, linear relations. I expect these notes to be filled out that I've given you. And so when I take up your homework, you'll get a grade for notes and for homework. So if they need to be completely filled out based on whether you watch the video or not. And then I want you to do all of the homework, not just the evens or odds, because you're going to have time in class to do that. Let's get started. When points on a graph lie along a straight line, it's called a linear relation. And you can see in this first example that we've got a linear relation there. And it's right. I'm going to highlight it in yellow. Okay, a line also has arrows at both ends. A line segment has endpoints at each end. Linear relations can be represented by an equation. Every line has a name, I always say, and its name is its equation. And that is what that looks like. Just like Vincent looks like Vincent, and Jameson looks like Jameson, and Micaiah looks like Micaiah, and their name goes with their face. This equation goes with this line. So linear relations can be represented by an equation, and in this is x plus y equals 8. Now there's a couple forms that you can use. That particular form is standard form. And so I want you to write this down. Linear relations are often written in standard form, and that is, it's simply ax plus by equals c. And a, b, and c are integers, and they a, x, and y are your variables. Okay? Now, so what that means is you want your x and your y on the left side of the equal sign and your constant on the right. You may have to combine some things to get there. So let's look at the next slide we have. And for slide 2, the instructions are, and this is also on your paper, there's 6 problems. It says write each equation in standard form. So we're going to do that. Now, one thing you need to know about this is the first x should never be negative. And so I'm going to write it up here at the top in white. So the coefficient for x should not be negative. That's the number in front. The coefficient is the number in front of x. Coefficient of x should not be negative. Or a fraction. Okay. You want to change it to a positive, x to positive, and you want it to clear a fraction if there's a fraction. So we look, and the 5 is obviously negative, so we're going to divide everything by -1 in this first problem, so that the x becomes positive. I'm not worried about the y. I just want that leading coefficient x to be positive. So this is going to become positive, so that's 5x minus 6y equals positive 12. And so now that is in standard form, and that's the form you want it. When you say standard form, that's what I want it to look like. Now the second one is in slope-intercept form, if you remember that. So we've got to move the x over here, and when we do that, we're going to subtract 2x from both sides. So we end up with negative 2x plus y equals, and that adds to be 0 there, negative 9. Now again, I don't want a negative x, so I'm going to divide everything by -1. And that's going to leave me with 2x minus y equals positive 9. Now notice on your test, some of you are having sign issues. You really have got to start being very careful about these signs. Okay, and I'm going through this fast, so if you have to stop the tape, stop the video, think about it, take some time to write it down. I can go fast and it doesn't hurt anything because you can always stop and start it when you want. Alright, now look at, we have a minus 24 here that doesn't need to be there. We need that to be on the other side. So we're going to add 24 to both sides. And so now we have 9x plus 6y equals 24. Now, if you want it in lowest terms, which you usually do, you factor out your greatest common factor. And so that means you divide by your greatest common factor, which is 3. And I'm going to put this little arrow here and say that that is the GCF, just so you know what that is. And so our final answer would be 3x plus 2y equals 8. It's kind of like you need to reduce a fraction. You have to get your equation in standard form in the lowest possible terms. Alright, 3 more examples here, and then we'll move on. We've got to add 7x across. So we add 7x to both sides. So we have 7x plus 7y equals 7. And our GCF is 7. And everything it was divisible by that. So I'm going to divide by 7. And my final answer is going to be x plus y equals 1. Okay. Now we have a fraction. And remember, to clear a fraction, you multiply everything by the GCF. And so we can use our GCF, which is 12, to clear out the fraction. So that means I have 12 times 3/4 x minus 12 times 1/3 y. And don't forget, you have to multiply it by everything. So over here we have 12 times 1. So there's a couple ways you can look at this. You can multiply across the top and get 36 over 4 x. Or I can say 4 goes into 12 3 times. 3 times 3 is 9x. And 36 divided by 4 is 9. So it's the same thing. This is going to be 12/3 y. 12 times 1 is 12. 3 times 1 is 3. Or 3 goes into 12 4 times, and so that's minus 4y. And 12 times 1 is 12 on the other side. And so that will be the final answer. There's nothing that I can divide into all of those. There's not a greatest common factor. So we're through with that one. And number 6, we have a fraction. So we're going to multiply everything through by 6. All of this by 6. Which means I've got 6, which is 6 over 1, times 1/6 x equals 6 times y minus 6 times 2. Those cancel or become 6 over 6. So we have x equals 6y minus 12. And I'm going to subtract 6y across. So I have the x's and y's on the left side of the equation. Okay, and so my final answer then is x minus 6y equals negative 12. And that 12 has to stay negative over there. And y'all are going to really have to start watching with your positive and negative, some of you. All right, so that is linear relations. It is standard form, and it's how to move things and change them into standard form. So now our next part of the review is to talk about slope-intercept form. Okay, in slope-intercept form, is it is y equals mx plus b. Okay, so there's two. It's y equals mx plus b. Okay, and the other way to write that is function notation, which we haven't really talked about functions yet, but we'll start talking about them more and more. You should have done this in Algebra 1. But function notations is, instead of y, you have an f of x equals mx plus b. So basically it's the same form, it's just one is written in function notation. Okay, where m, if you remember hopefully, is the slope of the line, which is also the rate of change of the line. I'm going to write that underneath. Rate of change. And b is the y-intercept, or where it crosses the y-axis. And the y-intercept is a point. And the y-intercept point, if you remember in your coordinate plane, points are listed x and then y. And on the y-axis, the x is always 0, and so it'll be some number b is your y-intercept. So it is a point on a line. Okay? So slope is the constant rate of change between points, and the thing we talk about is rise over run. It's y over x, and so that's why rise is up and down, and so it's y over x. It's really the change in y, which is delta, and in chemistry you should start seeing that that means y1 minus y2 minus y1. It's the difference in the y values minus the difference in the x values, or divided by the difference in the x values. There are 4 types of slope, and so I might ask you to sketch these or comment on these for the test when we have one. But a positive slope, if you graph it on the coordinate plane and you have your x and y axis, okay, I'm going to draw it in here with a different color line. A positive slope goes up and to the right, or down to the left. Okay. Or, if you want to say in words, it is increasing from left to right. Okay. Then one other slope is a negative slope. And if you draw your x and y axis and put the line on the graph, it looks like this. Okay. And so it is decreasing from left to right. It's going down, or decreasing from left to right. Okay? Then we also have zero slope. Okay? And zero slope is a horizontal line. And these are these you just have to memorize. It's easy to confuse zero and undefined or no slope, but zero is a horizontal line. It's also a y equals line, always. Y equals some number. And you have to memorize that. So I'm going to put this here in parentheses. That one's y equals some number, b. Okay? And it is horizontal. Some of you have problems remembering what horizontal and vertical means, so this is a good time to get that straight and to learn to memorize that. And the last slope is undefined. Sometimes they'll say it's no slope, but that's a little bit confusing because we also talked about zero slope. So undefined. And that's x equals some number. I'll put an a. Okay? And when you graph that, an x equals line is a vertical line. It's straight up and down. Okay. Okay, so it's a vertical line. So on our next slope, well, we've talked about slope and what it is. It's rate of change. We've talked about the 4 scenarios that we've got for types of slope, what type of change. Now we're going to write equations in slope-intercept form. So we've got 4 equations here, and it says to graph the line. Well, the first one is already in slope-intercept form. So if you remember, it's y equals mx plus b. And I'm going to write that along the top just so that you remember y equals mx plus b. So you want it to be a y equals line. That's what you look for. And then you figure out what your slope is and what your intercept is. So in number 7, m, the slope, is 2/5. And b is equal to 7. Now it's a positive slope, so we know that it's going to lean up and to the right. Okay, so we always start with our y-intercept at 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Put a dot there. And then we can count up to and over 5, or we can count down to. So 2/5 would be up to and right 5, if we were counting our slope. Or I can use -2 over -5 because that's also positive 2/5. Which means we can count down to, because that's negative direction, and left 5. So if I go down to here, I can go down to and over 1, 2, 3, 4, 5 and put a line. Okay, so this is down to and left 5. And then there's really not a... I can't go down 2 and over 5 anymore, so I'm going to have to just draw my line through that point, such as it is, and try to hit that point. Okay, so there's a line that goes through, some arrows on the ends, through those 2 points. Okay, and the name of that line is y equals 2/5 x plus 7. Alright, so let's look at the next one. This one is y equals, always change an f of x to y equals. So it's y equals, and that negative means that's a -1 there, plus 2. So my slope is -1, and my y-intercept is 2. Well, how do you count a negative slope, okay? So that's either -1 over 1, which would be down 1 and right 1, negative in one direction, or it's 1 over -1, which would be up 1 and left 1. Okay? So you can count down and to the right or up or to the left, but either way, you know that this line should go up to the left and down on the right. It's decreasing to the right, increasing to the left. Okay, so we start with 2. Go to our y-intercept first and put a point at 2. And like I said, you can go up 1, and I'm going to plot the points in different color, and I'll go ahead and red. And go up 1 and over 1, up 1 and over 1, up 1 and right 1. Oops, no, I'm doing that wrong. Okay, I've got to go up 1 and left 1 if I want to go negative slope, or I've got to go down 1 and right 1. And you can get a lot of points in there to where you can draw a nice line through those points. Okay? So that is a negatively sloped line. Put some arrows on it. Alright, then we're going to look at our next line, number 9. This is in standard form, so we've got to change it to slope-intercept form, because that's what we're going to, it's easier to graph in slope-intercept. So we're going to subtract x and subtract x, which means we have 3y is equal to -x minus 15. Okay? Now I want to divide by 3. So now I just have 3 over 3 is 1. So I have y equals -1/3 x minus 5. Okay, so it's a negative slope. The line's going to graph like that. It's negative, so it can be counted either -1 over 3 for our slope or 1 over -3. But that is our slope, and the y-intercept is -5. So we're going to go down to -5, 1, 2, 3, 4, 5, and put a dot. I'll graph this one in blue. Okay, so again, we can count it. This first example is down 1 and over 3. Down 1 and right 3, so I could go down 1 and right 3. And I could go down 1 again and right 3 more. I just kind of keep going from each point. Then I can go back to the y-intercept, the black dot, and I could go up 1, but I have to go to the left 3, because I have to go negative in one direction to have a negative slope. And that's about all I can draw on there. And so let's see if we can get a good line through here. Should have made it blue. But anyway, that's the line through those points. Okay? I'll make it blue. You might hear my dog barking in the background. She's having a dream. Okay. Guess she's chasing rabbits. Okay. Now the last one on this page. Again, now I've got everything on the left. I need to move the x and the y over. So that's minus 4x, excuse me, not the x and the y, the x and the constant, and plus 1. So it's minus 4x and plus 1 over here. So my x's and y's add to be 0, and all I have left is a y equals negative 4x plus 1. Okay, so my slope is negative 4. Now that's also negative 4 over 1. Since it's negative, it's going to be up to the left, like this, like with the last few lines. Or I could do 4 over negative 1, and my b is plus 1. Now you're going to see that this is a steeper line. When you have a whole number, a fairly good size whole number, it's a steep line. So we go to 1, it's our y-intercept, and then I'm going to go up 4, 1, 2, 3, 4, and left 1. I go negative in one direction. Now I can't go up 4 or more, so I'm going to have to start at the black dot again and go down 4 and right 1. And I could do that again, 1, 2, 3, 4, and right 1. And it's better to have 3 to 5 points rather than 2. Sometimes 2 is all you can get on the graph, but the more the better for drawing a nice line. Okay. And so we have a line here that represents y equals negative 4x plus 1. So now we've graphed lines in slope-intercept form. We've put them in slope-intercept form. We've put equations into standard form. Standard form you can graph from, but we'll have a different strategy for graphing if you have standard form here in a little bit. So let's move on. You know, if you want to stop at any time and work on a little homework, take a little break from the notes. But you remember, you have to have these filled in and turned in as part of your assignment today. So we have vertical and horizontal lines now in this next section. And it says, write the equation of the line. Well, let's look. A vertical line, if we look at this line very closely, and you have your notes, this is negative 1, negative 2, and negative 3. Okay? It's hard to see, but that's negative 3. And each of these, no matter where you go, no matter what your y value is, okay, so in other words, this point right here is negative 3 and 1, 2, 3, 4. Okay? This point is negative 3, 1. If I go down here, this point is negative 3, negative 3. So my y differs, but my x is always the same. And so that's why a vertical line is an x equals line, and this line is x equals negative 3. No matter what your y is, your x is negative 3. And a horizontal line is the same. You think of it the same way. If you look at where it is, no matter what x, okay, this x is 1, 2, 3, this is 4, this is 1, this is x is 2, okay, but no matter where I am on my x, my y is equal to positive 1. So the equation for this line is y equals 1. Okay? So a horizontal line is a y equals line. A vertical line is an x equals line. Parallel and perpendicular, you may have not talked about a whole lot in Algebra 1, but you might remember. You probably, if you're from geometry, you talked about them. The slopes of parallel lines are equal. They're the same. Okay? The slopes of perpendicular lines are negative reciprocals, or opposite reciprocals, some people say. So negative reciprocals. That means you flip the fraction over. Okay, so negative reciprocals. Right, so that's that little portion of your notes talking about vertical and horizontal line and parallel and perpendicular lines. And then our next part of our note says determine whether the lines are parallel, perpendicular, or neither. Okay, so what you have to do is find the slope of the two lines. Now, you can get them in y equals mx plus b form. That's the easiest thing to do. So let's look first at our, let's go here. And number 13, we're going to leave the 5y, and we're going to subtract the 10x over to the right. Okay? So you're left with 5y equals negative 10x plus 5. Alright, so then you're going to divide by 5. So y equals negative 10 over 5x plus 1. Okay. So slope is going to be negative 10 over 5, which is negative 2. Okay. So the next line, I need to move the x over here so it'll become plus x, and move the 2y over here so it becomes minus 2y. So we end up with negative 2y equals x plus 16, and divide by negative 2. Okay. So this becomes positive y equals negative 1/2 x minus 8. So the slope is negative 1/2. Okay, so I need it to be, if it's parallel, and the symbol for parallel is this, they would have to be the same, and they're not. So they're not parallel. Okay. If they're perpendicular, they would have to have different signs, and they're both negative. So it's not. It's not either one of those. It is neither. If you didn't hear my explanation, rewind and hear it. They're not the same. They're not. It looks like it could be a negative reciprocal, but they can't be the same sign. Okay, so we want to leave the 6y. We're going to subtract 8x. So we have negative 6y equals negative 8x plus 42. And then we're going to divide by negative 6. So y, and we're going to reduce 8/6 to be 4/3 x plus 7. Should be minus 7, sorry. Because that was a negative 6. Alright, so m here is 4/3. So let's think about it. For a parallel line, in our second one, m2 would be 4/3 if it's parallel. If it's perpendicular, m2 would be negative 3/4. So we have to figure out, let's go over equation 2 and see if we have either one of those two things. It's already set y equals, except we need it to be just y. So we're going to divide by negative 3. So we have 1y, and so this is going to become 1y, and that's positive 4/3 x. I'm going to put that first because it's mx plus b, and then minus 3. And we see that m2 the slope for line 2 is 4/3, which is the same as M1. So they are, when they graph them, they are parallel. They do not have the same y-intercept, but when they graph, they will be parallel lines. They will never cross or touch. They will run alongside one another. Okay, let's look at 15. Again, I know I'm going fast through this, but stop and think if you need to. Alright, so I'm going to move the 8x over. Then that's going to become 8x over here. Okay. So, we have 8y equals 8x, or y equals x. Well, if we think about it, that's y equals 1x plus 0. M, our slope, is 1. Okay? There's not going to really be a negative reciprocal for 1. But so let's see what we have here. We have negative y equals negative x plus 4. We're going to bring the x over and it becomes negative. Then we're going to divide by negative 1. So y is equal to x minus 4. And so the slope here, if there's nothing there, it's a 1. So these will also be parallel. They both have a slope of 1. Okay. And our last example, we have x equals 2 and y equals 2. Well, this is one of those cases where here the slope is undefined for x equal, and the slope here is 0 for y equals. But we know if we graphed these that, I'll do this one in yellow, x equals 2 would be right here. It's a vertical line at x equals 2, and y equals 2 is going to be a horizontal line at y equals 2, and vertical and horizontal are going to make right angles to one another. So this one is perpendicular. Now this is the one you'll see quite often on various type tests sometimes, because they want you to be able to recognize that those two are perpendicular to one another, and they're checking to see if you know the slopes and without having slopes, like a non-slanted line. So you see some of these things on standardized tests sometimes. Okay, so those two things are perpendicular. So we're moving on, we're getting there. We've got a few more slides. This one, we're talking about x and y intercepts. That's where it crosses the x-axis and the y-axis. Now in this particular graph that's here, in this particular graph that's here, you've got, this is your x-intercept, and that is -3, 0. And up here is where it crosses the y-axis, and that one is 0, 4. Okay? The x-intercept is referred to as a root. When we get solutions for quadratics, we'll be finding x-intercepts. So x-intercepts can also be called a root, a 0, or a solution to the equation. Okay? So, to find the x-intercept, we notice we want to find the x-intercept of the equation y equals negative 2x plus 5. So to find the x-intercept, you set your y equal to 0 and solve for x. Okay? To find the y-intercept, you set your x equal to 0 and solve for y. So, for the x-intercept, we've got negative 2, y equals negative 2x plus 5. And for the x-intercept, it says set y equal to 0. So you have 0 equals negative 2x plus 5. And then you're going to subtract 5 across. So you have minus 5 is equal to negative 2x. And then divide by negative 2. So x is equal to 5 over 2. Okay, and as a point, that's 5 over 2, 0, because the y is always 0 where it crosses the x-axis. Now when we do the y-intercept, okay, again we have y equals negative 2x plus 5. So in this one we set the x equal to 0. So y equals negative 2. Then we put a 0 in for the x. Well, 2 times 0, all of that's 0. So y is equal to 5. And so my point, again, x is 0 and y is 5. And that's the y-intercept as a point. And they should be reported as a point. They are points. Okay, so that's quick notes on x and y intercepts. And this one is easier. Many times you see these when you're doing standard form. If you know how to do this, you can stop this. I do want you to fill out the notes at some point, but if you want to go ahead and start on your homework for a little bit, that's fine. But I'm going to work through the rest of these examples. So, for the x-intercept, you'll have 0 equals 5x minus 1. Okay. For the y-intercept, you'll have y equals 5 times 0 minus 1. So y will be negative 1. Or 0, negative 1 is a point. And over here, you're going to have 1 equals 5x when I add 1 to both sides. And then you divide by 5, 1/5 is equal to x. So you have 1/5 and 0. Okay? So when you get on a graph, then you have to estimate. 1/5 is like 0.2. So you're going to go right here. And then I have 0, negative 1. So right there. So it's really hard to draw. You need a ruler. Hopefully you have a ruler. But then you'll just draw that line in as best you can. I don't have a good ruler, so my line may curve a little bit. But that's your line. Alright, let's look at 2. Example 2. Okay, so for the x-intercept, we're going to have 0 equals negative 6/5 x plus 2. Subtract 2 from both sides. So negative 2 is equal to negative 6/5 x. Now, if I want to, I can multiply by 5 on both sides so I don't have a fraction. Okay. and that'll be negative 6x equals negative 10. And then negative 10 over negative 6 equals x. And reducing that fraction, it will be positive 5/3. Okay, I could have multiplied by the reciprocal, 5/6. If you want to do that, it's up to you. So my point is 5/3, 0. And 5/3 is close to 2. It's not quite 2. It's 1 2/3. Okay, so now let's look at y equals. So for the y-intercept, y equals negative 6/5 times 0 plus 2, or y equals 2. And so the point is 0, 2. Alright, so I have a point here at 1 2/3, and at 2, that would be a negative slope. And then we're going to draw the line. Okay. So there's a couple more slides, a few more problems. Let's get busy on those real quickly. Okay, this one, probably the easiest thing is going to be to multiply by 3 everywhere, because I've got a fraction in number 3. So I'm going to multiply 3 here, 3 here, and 3 here, and it will cancel there. So I end up with 3y equals negative 9x plus 16. So if I make y equals 0, I have 3 times 0 is equal to negative 9x plus 16. That becomes 0, and so I can bring the 9x over and have 9x plus 16, and x equals 16 over 9. And so it's a point 16/9, 0. Okay. For our x-intercept, I can say y equals negative 3 times 0 plus 16/3. So y is equal to 16/3, and is a point that's 0 and 16/3. So that's 5 1/3 if I'm trying to locate it, and 16/9 is 1 7/9. Okay, so I'm close to 2 and close to 5. So I'm close to 2 here on the x-axis. And I'm a little over 5 on the y-axis. Okay. And then plot my points. Curving around kind of there. Okay. And that shouldn't be there. Okay. Now let's look at 4x minus y equals 8. Subtract 4x from both sides. Negative y is equal to negative 4x plus 8, and divide by negative 1. You don't really have to do this. In fact, let's not do this. Let's go back and just, let's make it, don't do all that. That just makes it harder. Okay, so for my x value, for my y-intercept, let's do x-intercept first. I make y equals 0, so I have 4x minus 0 equals 8. 4x equals 8, so x equals 2. and the point then would be 2, 0. And for the y-intercept, I have 4 times 0, my x equals 0, minus y equals 8. So negative y equals 8. So positive y equals negative 8. And so that point is 0, negative 8. Alright, so I have a x value of 2 and a y value at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Way down there at the bottom. And then I have to try to draw a line, a nice straight line through them. Okay. Alright, so that's x and y intercepts for those two. I have 3 more. Okay. And you know, these might get a little harder. But again, when they're in standard form like this, it's really not that bad. We're going to first do our x-intercept, which means y equals 0, right? So we have negative 5x minus 4 times 0 equals negative 24. That's 0. So negative 5x equals negative 24. And divide by negative 5. So x is equal to 24 over 5. Now that's a fraction. The x value is 24 over 5. That's not quite 5, it's close. And 0. Because 25 over 5 would be 5. Alright, then we go over to the next one. For the y-intercept, you make x equal 0. So we have negative 5 times 0 minus 4y equals negative 24. The 5 times 0 is 0. You end up with negative 4y equals negative 24. So when you divide by negative 4 to get 1y, y is equal to 6. And so my point is 0, 6. So I look up on the y-axis and count up 6 and put a point. And on my x-axis it's almost 5, but not quite. Just a little bit shy of 5. And draw my line as best I can. Not the best at line. Not the best at drawing these points, obviously. Okay, so that one was at 6. Okay, so there we go. Having trouble getting the point on there. Okay, so there's the line. Okay. So that is number 5. Number 6 and 7 have fractions. So let's multiply. Our greatest common factor is 12. I'm going to multiply by 12 all the way across. And that will give me 36 over 4, or 9x, minus 4y equals negative 24. For the x-intercept, I make y equals 0, so I have 9x minus 4 times 0 equals negative 24, or 9x equals negative 24, and then divide by 9. So x is going to be negative 24 over 9. Now I can reduce that. They'll both divide by 3. So that's negative 8 thirds. 0 is the point. For the y-intercept, I make x x equals 0. So I have 9 times 0 minus 4y equals negative 24. Or negative 4y equals negative 24, which is again positive 6, which is 0, 6 is a point. Okay? So negative 8/3 is negative 2 2/3. So there's negative 2 2/3. And then I want to go up to 6. And then draw the line. And the last one is also a fraction. So we can multiply through by, actually, we can just make a common denominator of 6. So we can multiply through everything by 6. So the 2 will go into 6 3 times. So it'll be 15x. 6's will cancel here, plus 5y equals 36. Okay. So in one of them, I'm going to make the x 0 plus 5y equals 36. Y is equal to 36 over 5. So x was 0 and y is 36/5 in this example. Okay. And then I'm going to make the y equals 0, so I have 15x plus 5 times 0 equals 36. So 15x equals 36. So x is equal to 36 over 15. And those will both divide by 3. So that would be 12/5, 0. Okay. So on the x-axis, I've got to go 12/5, which is 5, which is 2, and 2/5, or about 2.4. And then on the y-axis, I have to go 36/5, which is 6, 7 1/5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, and a little over about 7.2. Way up there at the top. And draw the line. So with x and y intercepts, you really only have the 2 points. So you really need a ruler because it's difficult to draw a straight line. So 2 points for x and y intercepts and 1 point for the other. So do your homework, fill out all your notes, do all your homework, get ready. I may have to have you start doing all your homework because I need y'all to be able to do these problems when we have a test. So I'll see you all next time, next class period.